Okay, starting this chapter, new chapter, chapter 3. First thing we're looking at is understanding what a solution to a line is. This is a relationship between x and y. Hey, somebody tell me, what form is this in? Standard. Everybody label that as standard. This will actually be used more in this chapter than it has in previous. So say, hi, standard, I might actually go to you now. This one's standard form also. That will be helpful later on. So is 1 negative 3 a solution? 2 times 1 minus 3 times negative 3. Does that equal 6? No, that becomes 2 plus 9, doesn't it? That does not equal 6. What about the bottom one here? Negative 4 times 2. Y'all believe so? Does that equal negative 5? Yes. Negative 8 plus 3 does equal negative 5. It does. Check. It is a solution. So sometimes that we would say then 2, 3 must have been on the line for that relationship. Down here, if you were to graph the following equations on the same graph, I don't know how you made your graph. Good job. Here I put them on. Oh, by the way, we got to get more comfortable with graphing. On this one, I used the y-intercept of 2. Use the slope. Down 3, over 2. I got to that point. There's a line. So this is the line. Y equals negative 3 halves x plus 2. Y equals x minus 4. Y-intercept of negative 4. What is that slope? 1. Up 1, over 1, up 1, over 1. So we'll put them both on one graph and then come over here and draw an arrow to where they intersect. It doesn't ask this. It doesn't ask what the solution is. But for this chapter, to reiterate, that is everything that you will worry about. Where they cross. The point they have in common. What does that solution have? It has two things. An x and a y. An ordered pair, a set of coordinates. An x and a y that satisfies both relationships. Okay, turn the page. First thing I want you to look at, we're talking right here, we were talking about systems of equations. Linear systems like this one right here. This is a system that's two linear equations at the same time. So in other words, this, put a star by this chart right here. This chart right here is homework questions, which will turn into test questions. When you talk about a system or two lines on the same graph, you're looking at it visually right here. Those two lines could cross each other. Those two lines could be the exact same line. I mean, same slope, same y-intercept. Or those two lines, what do we call these two kind of lines? They are parallel lines. Parallel lines have the same slope, different y-intercept. So this is a process of classifying. We could classify as independent, dependent, or inconsistent. Independent is what you'll normally see. One solution. Two lines cross one time. They're independent of one another. Dependent, right on top of each other, and inconsistent, never touch. So down here at the bottom, come all the way down to the bottom. Let's without graphing, we're going to classify each as independent, dependent, or inconsistent. So, both of these are in what form? Standard form. Awesome. What am I going to do if I want to look and I want to know their slope and y-intercept? Let's do it. Do it. 3x plus y equals 5. Do the algebra with me. The best way of learning algebra is putting a pencil in your hand and doing it. I've said that for 18 years, and it still is true. All right, so we're going to subtract 3x, y would equal negative 3x plus 5. That's the top one. The bottom one, 15x plus 5y equals 2. Subtract 15x. 5y equals negative 15x plus 2. Putting it in the slope-intercept form, divide the 5. Y would equal, we simplify this side, where the slope is negative 15 over 5. That is negative 3x plus 2/5. So when you look at these two lines right here and here, here and here, what do they have? Are they going to cross? Are they going to be the same line that's called deep-ended, or are they never touching, inconsistent? I hear some inconsistency, and how do you know that? Same slope, different y-intercept, so this is inconsistent. Very good. You'll have a homework question just like that. The next one, hey, one of them is already in slope-intercept form. Let's just take the second one right here. Let's add the 4x, add the 4x. 2y equals 4x plus 6. Divide the 2, y would equal 2x plus 3. By the way, I'm pretty confident in your ability to do the algebra now. If you are still struggling with rearranging equations, keep practicing. Keep practicing. You'll get better at it. Inconsistent. They have the same exact slope, the same exact y-intercept. No, they're not inconsistent. Inconsistent is when the y-intercepts are different. That means they don't touch. They have the same y-intercepts. They always touch the same line. So that is dependent. In the last one, rearranging these, we have the x minus y equals 5. Subtract the x, negative y is negative x plus 5. Divide the negative 1. Y would equal x minus 5. All right, up here, I can stop right there. This slope is 1. If we subtract the 3, the slope is still going to be 2, isn't it? If they have different slopes, how many times will they touch? One time. If their slope is different at all, they will eventually touch one time. It does not matter that they're both positive. One will be steeper than the other, they'll touch once. So we call those independent. All right, turn the page. Right here, this very first part says solving the system using a matrix equations have to be in standard form. Put a star, put 2 stars, put 3 stars by equations have to be in standard form. Oh my goodness, Mr. Bush, you do not like standard form. I don't. I do not like standard form, except for when I'm solving systems and I'm using matrices. Thankfully, they're already in standard form. If they're not, you have to be comfortable with the algebra and rearranging the equation. You want it to be ax plus by equals c format. We got that? That's number 1. Very important. So what are matrices? Matrix is a rectangular arrangement of numbers and rows. And it's always like row by column. Remember that. That's how you read this. So right here, label this one right here. This is a matrix. We got these numbers arranged in a bright. Raise your hand if you've ever worked with matrices. Anybody in this group? Okay, so it's all right if it's been a while. This matrix would be a 2-row by 3 column. So it's a 2 by 3. It's what you call that. The anatomy of a matrix is somewhat important for this lesson. Somewhat important. We have to understand the anatomy just a little bit. I turn the page. Speaking of the anatomy, if I just name these, this would be a 1 by 3. Label that a 1 by 3. It's got 1 row, 3 columns. This would be a 2 by 1. 2 rows, one column. So rows are the horizontal, 2 rows, 1 column. This is a 2 by 2, and that's a 2 by 2. There's things you can learn on that. All right, turn the page. If two matrices are equal, if their dimensions are the same, so these two are equal, and we could see if they're the same dimensions when you come down and try to do things like this, like add and subtract. They have to be the same dimensions. So I could add, we're not going to worry about adding matrices right now. That's a different time. But you would just add 3 plus 1, 4, negative 4 plus 0, negative 4, 7 plus 3. 10. So we could do this. Common elements. We could add, we could subtract. Down here, though, write a no. We could not do this. This is a 1 by 2, and this is a 2 by 2. Now that's only, we're talking adding, subtracting. Now multiplication, there's other rules. We'll talk about that later. Turn the page. This is called scalar multiplication. You can do that. That's just taking a number on the outside, and it's like distributing it to everything on the inside. So we could do scalar. We could do scalar here, then add. And then we come all the way down to solving a system. Okay, solve this system. If we were to put that system into this matrix equation, there would be one way of doing it. I'll demonstrate in just a minute. But imagine if you had this equation, 1/3 x equals 12. What would you multiply both sides times? 3. Very good. 3 over 1, that's the multiplicative inverse property, or the inverse property multiplication allows that to become just x. The same is true right here. You can multiply both sides times the inverse. Just remember that. All right, so let me show you on the calculator. Turn the calculator on. All right, on a fresh screen, if I wanted to solve this, I could take this side times the inverse of that. So first off, let's look at our calculator and learn where to find the matrices. There's a couple places. This button right here, if I want to, right here, kind of by the book, I don't know the names of the buttons. If I push that button, I get a lot of options. I could do a 2 by 2 matrix, a 1 by 2, or a 2 by 1. Those are some built in. Or if I go to that route, that one right there that's highlighted, hit enter. I can build a matrix of any size. So well, the first thing I need is a 2 by 2. So I didn't necessarily have to do that. So I'm going to hit 2, tab, 2. Enter. So I got a 2 by 2 matrix. Now, I'm going to delete that for just a minute. I'm going to show you another way. Hit menu. When you're on a calculator screen and you hit menu, you get all these options. Do you see anything up there that might be applicable to what I'm about to do? Yeah, I'm talking about matrices. Let's go to 7. 7, do you see anything there could do if I was trying to build a matrix? Create, maybe. So, create all kinds of, just a basic matrix. And it's the same window I saw a while ago. All right, what size of matrix do you want? Well, I do want a 2 by 2, so I'll just hit enter. There it is again. So there's 2 ways to build matrices. So what I'm going to do is I'm going to take, when you look at this system, remember both equations have to be in what form? We put 3 stars by this. Somebody say it. Standard form. So here they are in standard form. I'm going to take the coefficients of the x and y. That's what this is. 2, negative 2, 2, 2. That's these coefficients. Do that with me. 2, hit the tab button, negative 2, tab, 2, tab, 2. So I got them in. Now, I could solve this matrix equation just like the same concept here. If I can multiply this matrix times the inverse of that. Now I'm going to test your knowledge. Maybe one person in the group can teach me how to do mathematically to get an inverse. There's a way mathematically to get the inverse of this matrix. Anybody know this trick? I had one person in the morning that knew it. I'll give you a hint. It starts with this. Raise it to something. It's a good guess. Raise it to a -1. You ever heard of that? Anything to the -1 will be the inverse. So do that with me. We raise it to the -1. There is the inverse of that. There's a way of doing this. There's a mathematical way of calculating, but our calculators can do it for us, and it saves a lot of time. So if I took that answer and multiplied it to, what's our other side? -8 and 4. -8 tab 4. I get another matrix. What do you think that matrix is referring to? This is the whole chapter, the whole lesson right here, where they intersect. That's the X and the Y. That's the order they're in. X, Y. It's always that way. That is -1, 3 is the solution. Now, by the way, guys, this is not the easiest way. I was telling you your calculators will make solving systems easy. This isn't even the easiest way. You're about to really appreciate what I'm about to show you. I'm going to give you the secret sauce. You ready for this? Y'all want to know the best way of solving systems, at least in my opinion? Okay. I'm going to take one right off your homework. You're doing the evens today. You're going to say solve each system by graphing, check your answers. Right here's one. What's wrong with this first system? Now, what's crazy here, which one do I like? Do I like the top form or I like the bottom form? Bottom now because I need it in a what? For a what? Matrix. If I was graphing, now guys, you can graph, then I do like the top form. But I'm going to show you how to do this on a calculator without graphing, how to use matrices. Okay? So somebody tell me what is standard form of this guy, the top one. -x plus y equals -2. Thank you. So here is the trick. I want you to write this on your book. We're going to build a matrix with nothing but the coefficients. We have a -1, a 1, and a -2. That's the top equation. -1, a 1, and a -2. The bottom equation, what would it be? Somebody help me out. One, 1, 10. Remember that? Remember that right there. Hang on to that. On your calculator, go menu, 7 on the matrices, and I'm going to introduce you to something right here, number 5. Can somebody say that for me? Reduce row echelon form. This is the secret sauce for solving systems using matrices. So hit enter. And you notice it puts some sort of function on your calculator screen, RREF. You know what that stands for, reduce row echelon form. I'll go back and do it again. Pay attention, everybody. Menu. Not 8, 7. Matrices. And number 5. Reduce row echelon form. By the way, you can If you don't want to go to the menu and get it, I can literally, just like other things, I can type RREF. I can do that. That will give me the same function. You ready for it? Now, inside that function, put a matrix. What do we need right here? What is this? A 2 by 3? We need a 2 by 3. Now put these numbers in. -1, tab, 1, tab, -2, tab, 1, tab, 1, tab, 10. Enter. Where do you think the answer is? You see the answer? Maybe it's 6-4. You think the answer is 6-4? What was the question? Man, that's a great, we don't even know what we're doing RREF form, do we? Solving a system. Remember, the whole chapter is about solving systems and finding where the two lines cross. You think it told us? I wonder if they cross a 6-4. 6, just check it. Let's check this. What if I put a 6 right there? What does it give me here? If I put 6 right there, it gives me 4 there, doesn't it? 6 works. What if I put a 6 right there and a 4 right there? Does it work? Yes. 6-4 is the one point they have in common. RREF, I don't know if you realize it yet or not. It might still be clicking. This is the easiest way to solve systems. I love this way. It'll take a lot of work off of you once you start using the RREF. Say, thank you, Mr. Bush. Thank you, Mr. Bush. I wished I had this in Algebra 1, Mr. Bush. Yes, it's really nice. As long as you understand what you're trying to get. So the solution is 6-4. There we go. All right, I'm going to give you a worksheet.